For Chapter 4c, we're going to be looking at stoichiometry.
Stoichiometry. So notice it says board notes on this slide. This is not a topic that is easy to explain with PowerPoint slides. I have posted some videos of people explaining stoichiometry, and I will also be posting some videos of me working out stoichiometric problems. Okay, so I just want to give an overview definition of what stoichiometry is. So it's the calculations of reactants and products based off a balanced chemical reaction. Okay, so that's a official definition. So the reason that we have been learning how to balance equations, the reason that we have been looking at mole and mole ratios and calculating molar mass, all of this stuff is coming down to these types of problems. So we're going to be using balanced equations with coefficients to balance to make sure the atom counts are on the same side. And with these coefficients, we're going to further apply that to figure out the number of moles. So we're using mole ratios here. So in this chemical equation that I have, notice it's a combustion reaction. We just talked about that on the previous slide because we have a hydrocarbon with oxygen and the products are carbon dioxide and water. So these coefficients that are in front, and if there is no number in front, it's just we assume it's a 1. These represent the number of moles of each of those compounds. So if I were to rewrite this chemical equation and apply it to moles, I would be saying that there is 1 mole of CH4, and I'm adding 2 moles of oxygen to that to get out products, 1 mole of carbon dioxide and 2 moles of H2O. Okay, so we're going to use these mole ratios, this balanced chemical reaction, in these stoichiometric calculations. Here are just a few examples of the types of problems we're going to be applying. So I know that word stoichiometry is a big word. What we're doing is we're taking all of our conversions that we've learned and we are just applying it to a chemical equation. We're using information from a balanced chemical equation to help us solve these problems, to help us go between grams of aluminum to moles of O2. Because note, so far, with all of the calculations we've done, we've been going grams of aluminum to molecules of aluminum. It's always the same element. We're talking about the same element. But when we have a chemical equation, we can go between aluminum and oxygen and even to products if we want, aluminum oxide, because of these coefficients, because of these balanced equations. So be on the lookout for a video that I will be posting solving the problems that you see here and showing you exactly how we're going to apply chemical equations and stoichiometry to do these types of conversions, to go, for instance, between grams of aluminum all the way to moles of oxygen and back. So this is one of the last equations that calculations we're going to be using in this chapter. We're going to be taking theoretical yield and actual yield and calculating percent yield. So let's look at the definitions of theoretical and actual yield. So theoretical yield is how much product you should get according to the balanced chemical equation and how much starting material you used. We've actually done this in lab before, right? We calculate how much we should have made or how much we should have recovered. That's your theoretical yield, the maximum amount that you should be able to get out. Now that's different than your actual yield because your actual yield is how much you did get out at the end of the experiment. And as we've all seen, you don't get it all back because there's some residue in a flask or something was spilled. There's a lot of human error there. So the actual yield and theoretical yield do differ, and that's what this calculation is for, to figure out what percent do they differ. Okay. Some other definitions. We have limiting reagent and excess reagent. So what a limiting reagent is, it's the reagent in the smallest amount. Okay, and this is in moles, not in grams. Okay, so you need to compare mole amounts when you're trying to figure out limiting versus excess. So the limiting reagent is the one with the smallest amount of moles. And when this limiting reagent gets used up, the reaction is going to stop. The excess reagent is the reagent that is not the limiting reagent. So it's the one that you're throwing a ton into it. Okay, it's usually the cheaper of the two. So you're going to put a lot of the excess reagent in order to use up all of the limiting reagent. So excess reagent does not determine theoretical yield at all. It's the limiting reagent that's going to determine your theoretical yield, how much product you should get out. When you're done with the experiment, all of your limiting reagent should be used up, but you will have some remaining of the excess because you had excess of it in the reaction flask. I'll also be showing some calculations on how to calculate limiting reagent and figuring out theoretical yield. So be on the lookout for those videos as well. Mass percent of a solution. We've done this in lab as well when we did the sand and salt, silicon dioxide and sodium chloride, when we separated the two and we figured out the mass percent of silicon dioxide and the mass percent of sodium chloride. So here is just the calculation for it. So if you're figuring out the mass percent of something, so say it's silicon dioxide, you're going to take the mass of the component, the silicon dioxide, and divide it by the mass of the total solution. And since it's a percent, don't forget to multiply it by 100. Since we're talking about solution, I wanted to define what a solution is. So a solution is made up of a solute and a solvent. So say for instance, I take table salt and I dissolve it in water. One of those two components is the solute. The other component is the solvent. How do I know which is which? Well, let's look back up here at the definitions of solute and solvent. So a solute is the substance that is dissolved. It's the one present in lesser amount. So in that example, where I'm taking sodium chloride and I'm dissolving it in water to make a solution of salt water, my solute portion is going to be the sodium chloride because the sodium chloride was the substance that was dissolved, and it's also the substance that in lesser amount. Now this leaves the solvent. The solvent in this case is going to be water. Definition of the solvent is the substance in which the solute is dissolved. Another way to easily identify the solvent is it's the one in greater amount. These definitions are going to come in very useful in later chapters when we talk about solutions, solutes, solvents, and even learn how to prepare some solutions in lab.